welcome everybody to today's webinar, the 4 Paradigm Shifts for the Connected Car of the Future. Thanks for joining us today. I'm happy to present you today's speaker, Dominik Obermeier, who is the CTO and co-founder of HiveMQ. Dominik has a strong background in distributed and large-scale systems architecture and is an OASIS MQTT TC member. He's also author of the Technical Foundations of the IoT and conference speaker. We are also very happy to have today's guest speaker, Daniel Himmelein, software engineer and automotive expert at ESR Labs, who has a strong background in operating and distributed systems and computer networks. Daniel mainly works on automotive series projects for German OEMs, and he is the creator of the Mindroid application frameworks. We will kick off in a minute, but before we start, I want to let you know that all participants are muted. However, you can ask questions during the webinar by clicking on the Q&A box in your control panel. Questions will be answered during our 15 minutes Q&A session by Dominik and Daniel. If there's not time to answer all of your questions, they will be answered on our HiveMQ community forum. The link to the community forum will be shared with you afterwards. Additionally, we will also start a quick poll during the Q&A session, and we would be very pleased if you could feedback on this webinar, because this really helps us to improve our webinars. Yeah, I think that's everything you need to know right now, and I guess you're ready to go, and I will hand over to Dominik and Daniel.
So thank you very much, Verena, for the introduction. My name is Daniel from ESR Labs, and I'm glad to talk to you today about connected cars and IoT. According to KPMG, connectivity and digitalization is really the #1 trend in the automotive industry today. By 2022, there is the expectation that over 125 million connected cars have already been shipped. But right now, we also see some problems in the automotive industry when it comes to the connected car and digitalization. First and foremost, we don't see a real platform mindset for both the in-vehicle and cloud components in the industry. And due to that, there are no real SDKs and application frameworks that would or could guide developers to build applications and services which in turn create customer value in short time and good quality. Another problem are the static communication paths that are burned today into the in-vehicle and vehicle-to-cloud messaging systems. Extending the data flows and data items of communication often require going through lengthy processes on OEM side and cause a lot of trouble. And then I see some technology gaps on what would be technically possible and what is actually done or implemented. For example, often IoT systems are cold booted instead of woken up from a deep sleep, which is a kind of suspend to REM that you know very well from your smartphones. And that could be done in less than 100 milliseconds. But often, really, these IoT devices are cold booted, which takes several seconds. And for example, another thing is that often HTTP is used of MQTT when you actually need a fast and bidirectional asynchronous messaging path with quality of service levels. And the same is true when it comes to triggering these kind of actions on the vehicle side by slow SMS message delivery instead of using MQTT push notifications. I will show a quick example later on. Another problem is how software is developed and released today. I've seen several times that development branches have been freezed for anything except bug fixes and security patch lists shortly after start of production. And this way you cannot generate additional customer value in form of new features or applications when the product has already been launched and is already in customers' hands. So if you look on some of the remote door unlock applications that OEMs currently provide for Android or iOS, you see the dilemma very well. It normally works like that you have a smartphone app which can trigger the door unlock operation. It sends the request to an OEM specific backend system, and then the backend sends an SMS to the vehicle to wake it up and to start the IoT device. The IoT device in the bad case is then cold booted, which will take several seconds. In the good case, it's just resumed from a deep sleep mode. After that, the device then connects back to the OEM backend with HTTP or HTTPS to receive the jobs it has to fulfill, in this case, an unlock job, and then finally unlocks the door. This can well take 30 to 60 seconds and is not very good for customer experience. Dominik will describe an improved data flow with MQTT technologies later on. And because of that, we identified 4 paradigm shifts to make the connected car happen using a simple and robust architecture in order to make our customers excited about the possibilities ahead. First, I would say that we really need platforms and SDKs for both edge and cloud side as an enabler for productivity. Second, I would say using publish subscribe messaging instead of plain service oriented architectures adds robustness and removes dependencies from distributed systems like vehicles. Third, I would say you should base all communication on a unified and versioned domain model, which describes all data and actions inside and outside of the vehicle. And fourth, an adjustment of the development processes is needed to make them ready for online updates. I would like to start with a quote from Alan Kay, who once said that the key in making great and growable systems is much more to design how its modules communicate rather than what their internal properties and behaviors should be. And what this means is to keep the basic interfaces and architectural building blocks stable. You should build SDKs with sustainable, well-designed public APIs and with the goal to make your developers happy and productive. I would also encourage all architects to get the data flows between software components right and efficient in the beginning. Then the code would pretty much write itself. And you can, internal properties, you can refactor later on without changing public APIs. And a real important shift is that you should regard the vehicle as a software platform for applications and services, and the platform is accessed only by companion SDKs. The application framework would then be or act as a runtime for your applications and services. It would implement, or it needs to implement, features like deployment, logging and monitoring, debugging, automated testing, and so on. The platform and SDK also make sure that developers can focus on the business logic without the need of solving other problems, for example, like persistent storage or reliable backend communication. Applications would then be composed out of building blocks like application framework components, for example, also topic-based public subscribe mechanisms and domain model. And these building blocks or constraints would make sure and guide your developers to be fast and productive, and also to deliver good quality in time. If you take a look on what the platform is, there are some really great examples here. On the edge side, I would say one really extremely good example is Google's Android system for smartphone. Of course, also Apple's iOS is a good example. On the cloud side, I would say good platforms are this cloud agnostic container as a services platform like Kubernetes, which in conjunction with Apache Kafka can be used very well for microservices-based architectures. And since the vehicle itself is a heterogeneous distributed system, it consists of different domains that all have their needs and requirements. The embedded domain, for example, often has real-time and functional safety requirements and is resource constrained. The connectivity domain has security and best effort message delivery requirements to backends. The cloud domain, on the other side, must be highly available and scale worldwide across many regions, and best be cloud agnostic. And we see a big trend towards more and more Ethernet-based networking and communication within vehicles, which gives us a lot of opportunities in future. And since all these domains must interact with each other in a common reliable way, then MQTT would be a perfectly fit in here to connect in-vehicle domains and also the cloud domain. We will see in a minute why and how publish subscribe messaging helps here. But first, how does publish subscribe work in general? In publish subscribe messaging, a broker decouples producer and consumer to build loosely coupled systems and avoids a lot of dependencies between them. In this example, a vehicle publishes speed data at certain intervals or thresholds to a broker, and other clients can either use these data to visualize it or to do other kinds of computations on them. Dominic will talk about the benefits of using MQTT for edge to cloud communication later. So I will focus first on in-vehicle software architectures built on publish, subscribe, and MQTT. First, I would say publish, subscribe provides a simple, clean, and robust messaging system to build efficient data flows without the need to generate a lot of code around your data as compared to service-oriented architectures. Next, topics organize your data and facilitate fine-grained access control to them or to it. As already said, you decouple producer and consumer by a broker. And it also helps a lot for automated tests because they could hook up to the broker to stimulate actions and to validate results in one generic way. Furthermore, if all vehicle communication would be done via a broker, one would easily get access to a vehicle in a uniform way just by leveraging a simple publish subscribe API and domain model. So what's the domain model, you may ask now? I will clarify that in the next slide. Oh, sorry, after the next slide. I have one slide here that adds some more features which are present in publish subscribe messaging. One is that you have different kinds of communication, which is one to many, many to one, and many to many, which is totally different from a simple service-oriented architecture. Publish, subscribe, and MQTT also support data streaming, not just request response patterns. And that helps in generating high or building high throughput applications. So in my opinion, doing just plain service-oriented architectures, complex distributed systems a lot and add dependencies, mostly by generating a lot of code around your data, requiring some kind of service discovery to bring producer and consumer together, and worst, by introducing synchronous calls across device boundaries, which can make your system or applications less reactive and more error prone. Of course, there is a need for services and RPC, especially when it comes to controlling shared resources, like a telephony module, or when you want to do communication via a diagnostic session, for example, where you really want to have only one client in control at one point in time. But in the end, I really think that most communication in a distributed system is much better done with publish subscribe mechanisms and not using software or service oriented approaches all the way down. So now we finally come to the domain model. What is it? The domain model in the end defines or represents real world domain specific objects, processes, and rules. In the example, we see one piece of such a domain model, one single message for defining the vehicle location. Each message belongs to a topic, in this case, vehicle/location, has a version schema and a definition. A complete domain model for a whole vehicle would consist of thousands of such messages. For example, for door states, for door unlock actions, for Bluetooth connection states, for data describing the vehicle environment, like a temperature, or maybe even nearby vehicles and places like restaurants and many other data. The data is available for all in-vehicle systems, apps and services just by subscribing to the specific topics. And of course, the domain model would be part of the SDKs to form the base of generating customer value in the end. And also one nice feature is that the domain model is really easily extensible. So the domain model is a unified and versioned set of messages stored on various topics for all vehicle domains and the cloud. The versioning is very important since you need to evolve over time and due to the need that you have to provide SDKs with API levels. The message definition should best be done with an extensible interface definition language like Google Protocol buffers. It also has a lot of code generators for various programming languages. And since application developers should focus on the business logic, they should not need to cope with message serialization, deserialization, or with data transmission protocols. Therefore, it's really the job of the application framework and the SDK to hide all that from the developers. The fourth paradigm shift really is that you have to adjust your processes to make software updates first class. And in my opinion, the first thing you need to do is stop branching applications by vehicle models and model years and to start delivering features to all of your customers. Also, in this case, to older vehicle models. And this means that you must base your software development in general on application frameworks and SDKs. You should use agile and pragmatic methods to develop and test these applications. And you should work with small teams that by using the SDK will automatically obey to the overall system, architecture, design rules and constraints. And the constraints really guide developers here and help them in delivering high quality applications and services in short time. Now we talked a lot about these four paradigm shifts, but to make the intelligent connected car happen, but we missed one important piece in the whole story yet, and this is over-the-air updates, short OTA. And this OTA, in the end, brings all these paradigms to life and creates customer value by allowing for constant improvements with new features, apps, and services. And that even for old or older vehicle models because of this SDKs and API levels. This is why in the end, we at ESR Labs provide a full stack OTA update solution containing both the in-vehicle client for updating devices in parallel and also a backend solution for orchestrating software updates, including app updates. So our backend is also built as a platform with companion SDKs for different programming languages. On top of the backend platform, we use the SDK to build microservices like our OTA update solution or OTA update app. And also within our platform, we heavily rely on publish subscribe technologies like Kafka or MQTT. On vehicle side, then we use our Mindroid application framework as basis for an OTA update app that is able to flash, for example, multiple ECUs in parallel. The communication between vehicle and backend is mostly done with MQTT, while we do HTTP progressive downloads for downloading software images and apps from a CDN. So to sum up, in my opinion, a platform is really a product with conceptual integrity and not just a few features like deployment or logging. And because of that, a platform must include an application framework, an SDK with documentation, and so on. And a distributed system platform must also include publish, subscribe as a standard communication mechanism. And this together with this unified domain model builds the foundation for application and service interaction and easily enables automated testing. Furthermore, you should really focus on having small teams that continuously develop, deploy, and test these applications. So that's it for my first part, and I would now hand over to Dominic.
Yeah, so thank you, Daniel. So now as we've seen the four paradigm shifts that we see happening, that we see the need to happen in the automotive industry, let's talk about solutions. And Daniel already showed in the example of the over-the-air update mechanisms that publish subscribe mechanisms on the one side inside the car, but also in the cloud or for cloud connectivity are really the way to go nowadays. So one of the things we here at HiveMQ, what we do is, most of you may know HiveMQ as MQTT broker. And the HiveMQ MQTT broker is used a lot in the automotive industry for different use cases. And so we will quickly come back then to the over-the-air update, but I'd also like to introduce a few other use cases which you might find familiar if you're in the automotive industry, and why it is so important that we accelerate and change how we develop software for a connected car. So first of all, we have a lot of experience in the automotive industry. In fact, HiveMQ powers a lot of the car and connected car infrastructure from a lot of OEMs, and we're working in general with a lot of OEMs, so including BMW, Audi. We're working with Daimler. We're working with platform providers in the US with Series XM. We're working with Automotive, but of course also with a lot of tier ones. And in general, we help our customers creating car sharing services, building connected car platforms, and connected car services. And how do we do this? Basically, all of these these companies, and of course a lot of more, are using the enterprise MQTT platform HiveMQ. And this is actually really simple from a conceptual point of view. There are these MQTT clients, which is in the context of device to cloud communication, is the car itself, for example, but also it could be any other kind of devices. But usually when in the connected car context, we are talking about the car itself as a whole entity or the parts of a car. So it's a car actually consists of a lot of components, and depending on the architecture, a single car could have many connections to the cloud instead of one centralized connection to the cloud. And the HiveMQ platform is capable of running and operating millions of cars in production. So a single deployment can handle up to 10 million connected cars at the same time with high availability. And things like clustering high availability are of course important, because the main thing here is a connected car platform needs to be always online, needs to work all the time. And basically, even if there are some infrastructure problems, this means for the customer, for the operator of a car, that there's a service degradation. Either some critical services don't work anymore, which would be a problem, or what could also be the case, that some of the services under the hood won't work, like collecting data from the canvas or whatever the use case is. And HiveMQ itself is an MQTT platform, but also has very tight integration to other systems like Apache Kafka, some databases, OAuth servers, analytics platforms, and it offers an extension framework which allows our customers to also include the MQTT broker in the proprietary enterprise infrastructure and connect the broker with existing security systems and existing systems in general. And our customers program this themselves. But of course, also we have partners and we sometimes do it ourselves for our customers here. It runs on Kubernetes, on Docker, OpenShift, on-premise. It runs on bare metal. Basically, HiveMQ runs wherever you need it. While, of course, nowadays cloud platforms are pretty popular, especially in the OEM space, we see still that a lot of deployments are done on the in own data centers. So HiveMQ is deployment agnostic here. So one of the use cases Daniel talked about, which was some people here recognize this use case. So the remote door unlock and lock situation. How this is done traditionally is that a car, let's for example do this in a car sharing context. So if you imagine you're as a user, you wanna use a car which is basically standing in front of you, and you're using an app on your mobile phone which allows you to reserve and to basically rent the car, and then should unlock for you so you can use the car. So how is this traditionally done is that SMS is used basically from the phone to the car, but of course usually this is also done with a cloud platform also here, which was omitted here for simplicity. But the mobile device will talk to a cloud platform. The cloud platform will issue an SMS, and the SMS will then arrive at the car. And usually this car could be in deep sleep mode to preserve energy. If you're lucky, it's already booted, but it could happen that this SMS issues a cold boot. And what the car then does, it goes to the HTTP server, and and from the HTTP server, then you get the answer to unlock the car. So this is a pattern which was done a lot. The problem here is that it's really not very user-friendly what we have here. This could take up to 30 seconds or more, and this is an extreme problem for some use cases. And for example, one customer where we have a case study online which we can talk about, is a car sharing company called Drive now part of Share Now. And in the past, there was a similar architecture, and it could happen that if you wanted to use the car, that it took up to 30 seconds to unlock the car you just rented, which if you're a patient person could be okay, but especially if you're in a stressful situation, you run your errands, you have both hands full of errands, you just want to go into your car. And now imagine also here in Germany, it rains a lot, and it's also raining. 30 seconds is a very, very, very long time for a user. And so this was a problem. This was also a problem because the usability of the service itself suffered from the poor user experience. And one of the things MQTT and HiveMQ solution helped is basically to have up to sub-second response times to unlock these cars. And and this really provides always-on connectivity for all the devices, aka cars in this context, running on Kubernetes, and this really allows for low latency push communication. And of course, also what is important is when you talk about IoT communication, so-called quality of service plays a major role, because this quality of service allows that a message really arrives at the car, for example. And this is something an MQTT broker also should do. So how would this look like? How does the change architecture look like here? So what now happens is that that a device, a phone, could now directly talk MQTT from the phone itself. You can talk directly MQTT to a message-based broker, to his publish-subscribe broker, and the broker would directly push the message to the car. So you don't have this wait mechanism, because the car is always online, and the always online connectivity to the broker really allows the sub-second response times end to end. So which is pretty nice. And of course, in a real example, the broker would integrate with some security systems, to billing systems, and so on. So this is also, of course, omitted here for simplicity. But this is why an extension framework is so important, because you really want to have your broker integrate with a billing system, with a permission system, to make sure, of course, that the user actually is allowed to do what they want to do. So this was like a real world example, and also implementing the paradigm shifts, which Daniel just said. So on one side, the publish subscribe architecture, the software, the agile software development is also something that is super important here. We've seen here that this use case is also built on containers, and in general, this implements all the best practices Daniel showed. So HiveMQ really provides here persistent always-on client connections for the largest car platforms of the world. And you really have this instant communication with millions of cars, and you really have just a fraction of the bandwidth cost and of the cost itself for communication, because MQTT is a protocol which is used here. It fits like a glove to the automotive industry, because you save so much bandwidth. You get this instant push communication, and you can connect millions of cars with the same infrastructure. And even with HiveMQ, you can scale up and down your infrastructure as needed, especially if you are using platforms like Kubernetes. So you can even have this no-touch operations. And yeah, so it provides an open API, which enables custom integrations to enterprise requirements. Especially security is super important, but also things like billing systems and usage tracking systems are usually important. And so this is what we see is a lot used, and MQTT brokers need to be integrated to the enterprise infrastructure. And especially if you're in production, and so since we're running we have a lot of customers running in production, connecting hundreds of thousands, millions of cars. one of the things which really we learned over the years, and of course also our customers learned over the years, is observability and insights for operations is key. There are so many, let's say, vectors where something could go wrong. You have this mobile network, for example. You have all of these, let's say, moving parts. So there are a lot of things which could go wrong, and you have a lot of layers of abstraction. So you really want to know where is the problem, and then you want to fix this. And this is why we build tools inside HiveMQ, so you can operate a fleet of millions of devices, and you can get insights of what's happening on a communication level, and you can even interact and find really the needle in the haystack in case something goes wrong. Okay, so this was it from how HiveMQ fits in here. And now I want to give the mic back to Daniel, and he will wrap up the conversation for today.
So thank you. So I would like now to introduce ESL Labs a bit here. We started out as a full stack embedded software company in 2012. We don't do hardware system design, but we really start on the next level. So when we get customer boards, we really start with hardware software integration. We make sure that the bootloaders run there very well. We do device driver development, and then, for example, also we make sure that the operating systems like Linux, Android, or other RTOSes are working well on the boards. And then we bring application frameworks and middleware to these boards and make sure that they operate nicely in your edge or in vehicle systems. And then we also provide the facilities to build applications and services. And of course, we also provide SDKs to customers so that others can also join in here and build applications and services. But of course, if you want to do an end-to-end platform for software updates and over-the-air updates for applications and also on platform level, you also have to build on the cloud side. And this is why we have this knowledge and this platform also for the cloud side to build container as a service platforms. Of course, we leverage infrastructure as code here completely. So all our setups are fully automated, and you can make them run automated on AWS, Azure, and others. Then, of course, we use, as already said, publish subscribe technologies a lot to do the communication to the edge side, like MQTT and also Apache Kafka within the backends. And of course, as Dominic already said, logging is very important, where, for example, we do a lot with Elasticsearch and Kibana, and of course, a lot of other technologies to make your microservices-based architecture work nicely. And of course, we fully operate this with continuous integration and continuous deployment pipeline. So in the end, we are really a software tier one that develops, tests, and integrates all software components ready to use for our customers. So a quick conclusion here to sum up is that you should really build distributed system platforms with simplicity in mind. And this is also what drives us always all the way down on both the edge and the cloud side. And this requires architectures to be based on publish subscribe messaging for both in vehicle systems and vehicle to cloud communication. And as Dominic already said, it's really the case that the technology is there. So you should really close the gaps and put the right pieces together and make it work and make your customer excited. So in my opinion, really the OTA update solution is the key to bring the four paradigms to life and really think in customer experience and make customers excited. And one way to do this is for sure to do a remote door unlock application that works in less than 1 second at least. And yeah, I would like to close with another quote from Mr. Dijkstra, who once said that simplicity is prerequisite for reliability. And I would say reliability is in the end, quality is time to market, and this is in the end also customer happiness. And that's what we want to achieve for our customers. Yeah, thank you very much. And now we are open to questions.
So I just started our poll, so we would be very, very happy if you would answer it. Yeah, so that we can improve our webinars. All right, here we have a few questions already. So one is asked by Gene. He asks, on paradigm shift 2 slide, why are there 2 errors referring back to MQTT broker? Is there a reason for that? I think that's a question for you, Dominic. So this is the slide with our
yes, I think this is just the slide about the MQTT broker.
Yeah.
So basically, what is so nice about technology like MQTT is that it allows this bi-directional communication. So this means from a single connection of a component or a device, you get this device can, on the one way, it can publish data, but on the other hand, it also can receive data. So in this, and in the combination with this standing connection, with this always on connectivity, this really means you get this push behavior, this push communication for data you send, but you also receive data in milliseconds from the cloud, for example. So yeah, long story short, there are 2 errors here because this is really a bi-directional communication that is provided by MQTT out of the box.
All right. There's one other question by Andrew Kenworthy. He asked, could you say a few words about how you use MQTT with unstable connections? Do you use retention as per MQTT protocol version 5 or caching, e.g. setting clean sessions? How robust is the time to live feature in MQTT HiveMQ?
Okay, I think I can also quickly jump in here. So this is actually a great question because unreliable connections are, especially in the connected car space, really day-to-day business. And what is MQTT really is designed for unstable connections. So MQTT as a technology is designed for low throughput and high bandwidth scenarios, but it's also designed for these unreliable connections. So where you have, for example, a car which loses connections very often. And this means, this makes it a bit hard, of course, for the application programmer on the car side, but also on the service side in the cloud. And MQTT has some unique features here, like persistent sessions, for example. And the question here is specifically about MQTT protocol version 5 or the setting of the clean session. So usually what we see in most of the cases is in the connected car space, people are using persistent sessions, which means, for example, if a car drives through a tunnel, for example, where you don't have connectivity anymore, then the broker will basically queue messages for this specific device until it gets online again. So even in case the car is not currently online, still the broker is able to buffer the message and send it to the car as soon as it's online again. But also from a client perspective, MQTT libraries nowadays also provide their offline buffering capabilities depending on what library you're using. So for this kind of interruptions, MQTT is really built here. So persistent sessions are one key, and so the broker, there is a data retention here. So this is, I would say, a best practice if you can do this. And there's a second question here about a time to live feature in MQTT and HiveMQ. So there are basically two layers to this. On the one side, there's this time to live feature, this heartbeat mechanism, which is basically a ping and a ping pong or ping and response game, which also makes sure to not have stale connections. So this is extremely robust, and this works for millions of cars. And there's also time to live for messages and sessions. So let's do an example. For example, you would push out data, like for example, that an accident occurred on a specific street, and you want to push out this data to all the cars in this area. It could be that that somebody who has the car in the garage and then starts the engine 2 days later, and then has connectivity 2 days later, is not interested anymore that 2 days ago there happened an accident, because this issue is already resolved. So MQTT allows for setting these limitations, so these time to live features. So a message can expire, especially if these are short-lived messages. And this is also extremely robust. So this is used in deployments with tens and hundreds of thousands of messages per second, which are like, it's an incredible number. And this works pretty well. So HiveMQ is actually built for this kind of functionality.
All right, then we have here another question by Maesh. He asked, how is the authentication handled for mobile app and for MQTT client in the car from HiveMQ?
Yeah, I think I can also answer this. So authentication is a central part. So the thing here is you really want to have a secure deployment, because you don't want, let's say, to get a car hacked, and then this hacked car can access your infrastructure and sniff on all messages which go through the systems. You never will want it. So there are two keys here. It's authorization and authentication. And so since MQTT uses a centralized approach, a device, and be it a car or be it a mobile phone or mobile app, they both would go to the broker, and this broker would then integrate usually with a security system of the OEM. And it could either be that you're using X509 certificates and you have a PKI you're integrating with, or you have some custom system like a OAuth system, which the broker integrates with. And like in a very, let's say, for some deployments, actually are even databases. So you're just using a database where the permissions are, and as soon as a client connects, be it a car or be it an app, you would go to a database. The broker will go to a database and find out the right permissions. So basically, is the device allowed to connect? Is the device allowed to send messages, receive messages? To what kind of MQTT features are allowed? What topics can the device subscribe? So you have this super fine-grained permission control, and you can even integrate it to the systems you already have. And nowadays, a lot of users are using microservices for that. You can integrate. And we have even a so-called enterprise security extension for HiveMQ, which allows you to do exactly this. And you can configure from databases to LDAPs to proprietary systems to X509 certificates, all of the systems out of the box. And then you can even do things like that a mobile app needs like using password authentication, while a car can use certificate authentication. So this is super fine-grained. If you want to learn more about this, we're more than happy to show you the capabilities here.
All right, then we have a couple of other questions here. Someone who wants to stay anonymous asks, would you mind talking about the best practices, technologies, and approaches for a connected vehicle end-to-end, for example, ECU to cloud to mobile app? I think this is one for you, Daniel.
I mean, here's also MQT is a perfect fit in here. Also on one slide from Dominic, you could see it a bit. So that in the end, the key here is again that you could have or should have a centralized broker that decouples the system in the end. So you decouple the vehicle from the mobile phone, and this is done by the way that the vehicle publishes status or information to the broker, and the broker can then send it later on to the mobile phone, or in the case of this remote door unlock feature, the other way around, that the mobile phone gives a trigger to the broker in the back end, and the back end can then deliver this information to the vehicle as soon as it has woken up. And of course, this also works very well in conjunction with persistent sessions and with time to live on packages.
Thank you. Then we have another question here by Rohit Gupta. Do you want to talk about how to measure the MQTT performance, since millions of messages are supposed to be sent and received in real-time scenario? How can these systems be tested to handle that kind of load?
Yeah, this is a very good question and an important question. And so the answer is you should really test with millions of devices and with the message amount you expect. This is the only way, because the thing is not about the MQTT broker. It's about the systems as a whole. Usually what we see that are not the MQTT broker is a bottleneck, but some consuming services who do something with the data. But you're right, you need to test this. And there are open source tools available on GitHub. So the thing here is you will not test what you think you're testing. The open source tools on GitHub are unfortunately not sophisticated enough to test millions of devices, and actually usually don't measure what you should measure, like tools like JMeter or MQTT Perf or a lot of the other tools available that don't really work. So this is why we build our own tools. So our customers get access to this kind of tools. So and we also help them to test actually the devices. So we have this device simulator, which allows you to test millions of devices on real infrastructure, where you can spawn like real MQTT clients and with the real payload you're expecting. So you can also test your backend systems. So this is something we do, and this is something we do with our customers, because usually these are the tests you need to do. Otherwise, you cannot extrapolate from a few thousands of connections and messages how the system will behave. This is unfortunately not possible, and so we always recommend to test with the real load you want to get to see what happens. And this is something we're assisting our customers also with.
Yeah, so maybe to hook in here, this is also something that we do, for example, when we build our backend solutions for example, for this OTA update. So let's assume we have to do 20 million OTA updates in 1 week. Then of course you should test that before or while the development of such a system. And in the end, like Dominic said, you should really test it. You should not work on assumptions or statistics. You should really do it. And the best way to do it is to really simulate that number of clients also using the cloud, and make sure that your system scales and performs well under this load.
All right. And I think we just have, so we have 5 minutes left. Then we take, I think it's, Rohit says, thank you very much. I'll get this one we can ask here. Asked by Santosh. Let's say MQTT broker fails due to some unexpected reasons. Hypothetically, does it always have a backup broker? If yes, how much time does it really take to shift to the backup broker, HiveMQ MQTT broker?
Yeah, it's also a good question, and this is an important question, because if you look at the MQTT communication paradigm, you always have the centralized communication, which is great. But this is why you should really make sure that you have a broker which supports high availability and clustering. So because you usually don't have one MQTT broker, what you do is you have a cluster of brokers, and in case of HiveMQ, if you have multiple nodes, Clients, of course, if a broker fails for some reason, because if you're on Kubernetes and your pod gets destroyed, or you're running in the cloud and your infrastructure gets unavailable for some reason, then the other brokers will take care. And so basically all the devices will reconnect to another broker, and they can just resume. So it's really just for the end user. The end user doesn't recognize, because it could also be because cars are losing connections all the time, right? So if a broker fails, no problem. There are these other brokers in the cluster, and even for disaster scenarios, HiveMQ has backups. And on Kubernetes, we are going to release a Kubernetes operator very soon, which also has this automated disaster recovery mechanism. So this is really no touch here. Even if, like, let's say you have like huge issues with the cloud infrastructure, you can then move to a backup cloud infrastructure. So this is something basically HiveMQ was built for. Because most of the deployments we have are super mission critical, so reliability is absolute key, and this is what makes the HiveMQ technology so unique, that you basically have these failover mechanisms.
Thank you very much, Dominic. So we have just a few minutes left, and there's actually one question that I've prepared for Daniel. So my question is, Daniel, what is the field of application of Mintroid?
Yeah, Mintroid is in the end a set of application frameworks. There's a Java version and a C++ version, and also one version for embedded C++. But we mainly use it for IoT applications, so that we can. It uses the ideas of Android a lot, but it's a really tiny version of it. And we build tons of IoT applications with it that can easily be developed and deployed to our vehicles or our edge devices. And in the end, it's really about having components with life cycles, having awareness of edge features like, for example, deep sleep modes for wake locks, for connectivity, for telephony managers, and of course, for publish, subscribe and message brokers. And it really integrates that into one application platform, and in the end, one SDK with documentation, so that you as a developer can be fast and can focus on business logic, like you know it, for example, from Android when you develop applications for mobile phones.
All right, thanks. So I think that is a precise timing, because the time is now already up. So thank you very much, Dominic and Daniel, for your presentation and for being guest speaker, and you, Daniel, especially for being guest speaker at our webinar. For you to just a few information, we will upload our webinar on the HiveMQ YouTube channel, so that you can watch it again. And don't forget to subscribe to our newsletter, in which we will give monthly HiveMQ and MQTT updates. And remember, all of the questions we couldn't answer here will be answered on the HiveMQ community forum. We will also send out a follow-up mail with all the details. So thanks, that's it. I hope you enjoyed this session as much as I did, and see you next time.